Ladies and gentlemen, come gather in, come gather in, come gather around. Today, we're going to rebuild this 4L80E automatic transmission. We're going to add most of, but not all of this TransGo shift kit. We're not going to put in the separator plate, we're going to dual feed internally, but also we're going to rollerize the transmission. Not just the output, but also the reaction carrier, the direct drum at the center support, and the forward hub. So it should get rid of a lot of the slop, make it a whole lot stronger. We're going to also add a 6th clutch in direct and dual feed direct as well, but internally. So let's go! Alright, I picked up this transmission with a motor and a wiring harness and an ECU from a junkyard. Since I don't really know what kind of shape this thing is going to be, I take it all apart because I want to know what I'm going to get myself into. As I took everything apart, I checked all the clutch clearances and everything, and it was actually in remarkably good shape. So while this is not a full rebuild, it was a relatively thorough cleaning. I just did the upgrades where I needed to do upgrades and repaired whatever I found along the way. This is undoing the last part of the guts inside the transmission, tail housing, and the whole bit. We're going to also dual feed the direct clutch or 3rd gear. Part of that is removing the center seal at the apply piston in the direct drum. This allows the hydraulics to feed both halves of the piston itself and triple the force going to that piston. I'm going to be reusing the bonded pistons. There's a way we can make that work a little bit later on for adding a 6th clutch. Second thing you need to do with direct feeding is removing this 2nd seal on the center support, which helps feed the clutch piston. The case bushings on these 4L80s are notorious for walking out of the case. So they do sell a case bushing called a no-walk bushing. It's got a ridge on it and comes in through here. There's a crap ton of forces inside this transmission that shoves everything out to the back, and that bushing pops out. Some folks like to rollerize the output by using a Turbo 350 automatic pump bushing on the other side of here to get rid of the brass bushings. So I'm going to do that. Some folks online say use early pump bushing from a 4L80, which measures about supposed to measure 550, but I'm getting 535 on this, assuming this is the right bushing. And it's wider than this. It's supposed to be about 550. The step that it sits on is about 550. So this will protrude and it will support the bearing, but you still don't have a whole lot left in the case to hold it together. And you're still using part of this. This isn't being used, so why not use it? So I'm going to put in a late pump bushing, which measures 0.7. To get bushings out, I've just got an old punch that I ground kind of like this. It's got a bit of an angle to it and a bit of a wedge, like a snow plow or a train plow. And you want to make sure you don't have anything sharp on this side so you can pop that guy out. So put this in here and a few smacks. Bushings out. I'm going to use the late pump bearing. But because of my math, which I sketched out, I was kind of sketching out for a moment there, if I have a 480 land in here and I want 0.1 of the bearing sticking out the other side to support the roller bearing, I got to have 120 coming out the other side based on the thickness of this. So I took this back to the lathe, machined it deeper in here. So it's got a 120 shallow, I don't know if you can see that too well. So now the bearing sits in the proper amount. If you look at it just like so, it disappears right inside there about 1/8 of an inch. And then we're going to use a little bit of green scrubby to scuff up the outer side of the bearing, the inner side of the bore, and we'll use some red Loctite to hold it all together. Hopefully it works. I think I'm going to use a little bit of lacquer thinner to get rid of anything else on here too. So there are a lot of forces that come through the transmission all the way from the front through the way this transmission is designed and they end up at this back of the transmission. So almost everybody who builds a decent 4L80 or a Turbo 400 rollerizes the back. We're going to get into rollerizing more, but this is what you need to do at a minimum for rollerizing your 4L80. Yeah, let's see how it feels. Oh, she's a thing of beauty. Check this out. Like, that's it, man. Rollerizing the reaction carrier, we got to cut a groove 75 thousandths deep to fit a Turbo 350 pump bearing, which is 2.875 in diameter. So the reaction carrier has a fair bit of float inside the transmission. So what we're going to do is do some rollerization to get rid of that. There's lots of forces between the reaction and the output, which can cause some issues if this thing comes off center. So we're going to put a bearing in there, and then we're going to shim that bearing so that there's about 2 to 6 thousandths of free play inside. And I'm showing you how to do the measurement for that. Feel free to back up and watch through it again a little bit slower each time. You're going to measure the distance from the carrier to the main shaft, whatever that number is. Then you're going to shim the bearing that you have in between the two, kind of like so. In this case, I think I put a 15 thou shim in just to see what it would do. Then you're going to reassemble it, remeasure it. We do want to have a little bit of a play in there. So we're checking to see, we're shimming it to get the center support up. And then we just need to remove some shims and a little bit more for the clearance that we want inside the transmission. Rollerizing the center support, I confess I'm a little worried. I'm concerned because there's going to be a lot of stick out on this cutter. However, it's got to be cut to 2.875 outside diameter, which is pretty much where this ridge is on the outside. And it needs an inside diameter of 2.125, which is pretty much where this little tiny step is inside here. So if we rollerize this part of the transmission, we can take a bunch of the forces and stresses from the front and kind of disperse them at the halfway point of the transmission before it gets to the output shaft. Measure the height that it's at. That kind of becomes your zero. Then you're going to add some shims to get the hub 5 to 10 thousandths off of the bottom. And then you're going to leave it there. You're not going to put any play in. We're going to get play somewhere else. Stick it all in together, and we got to put in the snap ring and check what our rear end play is for the transmission. So we're going for 3 to 8 thousandths rear end play. Mine needed a 15 thou shim to give me 5 thousandths of end play at the back of the transmission. Make sure you put the bearing the right way around. New center support bolt, torque, hopefully it doesn't break, and then you start reassembling the next part of the transmission. While you're at this part, another weak point on these transmissions is the intermediate snap ring. The TransGo shift kit that I'm using comes with one that I'm told is from a 727 Chrysler. Way back, you saw me take the direct drum. I took the piston out of it and I took out a middle seal. We're dual feeding this. So dual feeding takes away, like GM uses half, like the outer half of this and the inner half of this for two different things. There's a seal in the middle. You get rid of it. Then we can use the whole freaking piston to apply in third and reverse, but mostly we want that for third instead of half of the piston's surface area being used for third and the other half for reverse. We're going to use the whole thing. So the middle seal has been removed, which gives us the whole thing. Then we take out this wave plate. You can probably see how this is a little bit wavy, and this acts kind of like a spring. It cushions the apply of third or direct, and instead we're going to put in an extra clutch. So remove the wave, and the other thing I'm going to do is change all of the direct steels, which are 092 in thickness, and I'm going to change them all for 077s. Quick little tip, look for this V. This V on the corner tells you it is an 077. So you get a stack of those. 6 steels and 6 clutches. So I'm going to put these in. I like to align all of these up just in case there's a reason for it. Maybe that's how oil gets out of this, who knows. But I'm going to put them all the same. Doesn't matter where you put them, but I am going to stack them the same. So these frictions have been soaking in a bucket of ATF for a couple of hours, I think about 3 hours, and then stack them alternatingly till you get them all up to the top. And then you should check the clearance. I've already checked this. You want 10 thousandths of clearance per clutch, so you want 60 thousandths of play inside here. I've already measured this a bunch of times. If you don't know how to read a feeler gauge, if you don't know how to read a set of feeler gauges, you should not be rebuilding a transmission. So we're going to roll with that. Now I got to put the spring back on this. There is some interweb debate about whether you should actually install this or not. I chose to because it made sense to me at the time. But there is also a fair bit of discussion that the tin plates are pretty rinky-dink and you should probably change them for Turbo 400 parts so that it's a little bit more rigid. I'm going to see if it's a problem. The band is installed, and then the joyous challenge of trying to get all the splines lined up with the clutches. In rollerizing the forward clutch hub, you get a Ford bearing, which is no longer available, so good luck finding one. The one I have is 0.143 thick. That's thicker than the original. This guy is 63 thousandths. So I got to cut that out of the hub to fit this, which gives me 0.080. But we also want to make sure there is 0 end play. So we're going to subtract another 30 out of it, which gives you 50 that I have to cut off of here. Here we go. Rollerizing this also helps remove a whole whack of float in the direct clutch, and it also gets the direct hub off of the main shaft so that we aren't sending so many stresses into the back of the transmission. Once it's all assembled, we can put it into the transmission, and a whole lot of fun trying to get that together. And then we can work on pump mods. In here we're going to draw a 3/64. It's about a 0.050 hole right through here. Let's see if we can make that work. This, of course, is not a drill. It's a center punch. Sweet, done. Not scary at all. Well, usually drill bits follow holes, so I hope this follows it. Whoop. Yahtzee. So we got to take out the pressure regulator boost valve thingy. Whether you use a TransGo or the Sonnax boost valve, you should put one of these in your transmission. This is another area where these transmissions have issues. I think it's with like runaway pressure or inconsistent pressure. So I just used the one that came with my TransGo kit. A little bit annoying to put into. I probably should have clamped it into a vise so that I wasn't trying to hang on to it. But it's in. It'll work. There doesn't seem to be a huge, oh my gosh, don't use this one or you should use that one. Although, if you're not doing all of a TransGo shift kit, you can just use various Sonnax parts and do the same thing. While the rest of the bushings in the transmission looked really good, this pump bushing looked nasty. This transmission had been rebuilt by GM at some point, but I've heard that the GM factory authorized rebuilds are sketchy. This looked like it had never been replaced, so out it comes, put in another one, and that's the part number, a 34001. CSTG just comes with like Teflon and fancy coatings. I believe I used a bit of red Loctite to help knock her in. Used the same bushing driver that I used for the rollerizing in the back. Staked it in place, and that it probably won't go anywhere. Did drill the feed for the overdrive. I did not drill the little hole inside that some people do. I may regret that. It may not bother me at all. I'm not really doing long haul in overdrive. That's kind of silly. Put a little bit of grease on things, grease on a new seal, using parts that were at hand to pound the seal in. And then we can put that together. Handy trick, use a hose clamp, a large hose clamp, or a couple hose clamps to help hold the pump halves together while you're trying to align them to bolt them up. It gets them pretty darn good and goes into the case of the transmission just fine. Then we're going to be putting the pump into the transmission without the O-ring, but with the gasket, so we can check for end play. And we're shooting for about 2 to 5 thousandths more play than we had in the back of the transmission. The output shaft seal in the back of the case gets tapped into place, and then I put the snap ring in place and used the snap ring to set exactly how deep I pound the seal in. Also put in new bushing in the back. I'm here. It probably could have used it. Gave it a new seal, new O-ring, and slip her onto the back of the case. Just torque her down just gorgeous. The magic of the valve body. First, we're going to take it completely apart. I'm going to follow parts of the TransGo shift kit, but not all of it. We're going to add a few other things. Because we dual fed the third clutch internally, I'm not going to use TransGo's separator plate. Instead, we'll modify the existing separator plate. However, you want to get this thing really clean. And here's where you want to be very organized so you get everything disassembled the way you need it to be in order and you don't mix anything up. I confessed before running out and buying a long but narrow pair of needle nose pliers, I put one of my bent nose pliers in the hydraulic press and made them less bent pliers to reach one of the little pins holding this thing all together. You know, just being resourceful. A friend loaned me his TransGo AFL valve repair kit and let me use one of them to fix my valve body. Very kind. The other thing that I added to this build is a Sonnax overrunning clutch valve. Normally, if you're going to go do something stupid with your vehicle, you downshift into third and do your stupid things. But if you forget, the transmission doesn't apply an overrunning clutch. This little kit allows you to leave it in overdrive or forget to put it into 3, and it'll save your transmission, or at least give you more strength so you don't blow the overrunning sprag out of the front of your transmission case. It was an interesting installation. The instructions were really thorough and really good. It's certainly a quality and detailed piece. There is some discussion online whether this is necessary or not, but I see it as if I forget, or I'm out on the highway and I'm driving in overdrive and I want to pass somebody and I don't think about it, this thing at least can save my bacon in the future. I think it was worth it. This valve will get put on once the valve body itself gets put onto the transmission, so we'll just set it aside for now. And since there isn't a whole lot more to talk about on here, we'll just assemble a valve body while we're listening to the Valve Body Blues. back in the chassis. We fully rollerized the output, rollerized the reaction carrier, rollerized the direct drum, rollerized the forward hub. We've done extra clutch in direct. We've dual fed internally direct. We've added a couple of replacement valves, upgraded the valve body with most of a shift kit. We've also added an overrun clutch valve to keep this thing as strong in overdrive when it downshifts as it is if you went and physically downshifted. Hooray! Easy peasy. See me in 2 years when this thing's on the road. Check for a link somewhere. Until then, thanks for watching.